Hey everyone, it's Mrs. Hamby, and here's a couple more videos on absolute value inequality word problems. So here's the image that you saw in the Edpuzzle on Friday, or Thursday, depending on when you watched it. And here's another way of kind of talking about it. It's absolute value of x minus whatever is that perfect amount. So the one that's unchanged. And then this one is the one where you're going to either add or you're going to subtract to that number. Allowance deviation is what we call it, okay? And so it's always going to, not always, but for the most part, our absolute value inequalities are going to fall under this kind of pattern. We're going to have the absolute value of x minus, and then we're going to have a number that does not change. Typically, we use the less than greater, equal to inequality, but we don't have to, but for the most part, majority of the problems use that one. And then this is going to be where you're going to change your sign. So what are you going to be adding to that number? What are you going to be subtracting from that? All right, so here is a table of contents. You can just go ahead, I know we watched the Edpuzzle video, but you can go ahead and just add to those notes, or if you need to go on to the next set of note pages, that is fine. All right, so here's our first example. Example 1. The normal human body temperature is 98.6 degrees Fahrenheit. A temperature X that differs from normal by at least 2 degrees Fahrenheit is considered unhealthy. Write an inequality that could be used to determine if a temperature is unhealthy. All right, so obviously in this word problem, you want to always kind of circle the important stuff. So we know this one, this is going to be our perfect one. This is the one that's not going to be changing. And then obviously the 2 degrees, that's what you're going to be adding and subtracting. So that's going to be the one where you change that temperature by 2 degrees. So add or subtract that. And then the next important part is where it's talking about an unhealthy. Unhealthy. We want to know what's unhealthy. So let's just first describe what a healthy temperature would look like. So we know, obviously, if we have a temperature of 98.6 degrees, that would be considered healthy. And then if we are off by a little bit, by 2 degrees, so if we add 2 degrees here, then that would also be considered healthy, so 100.6. And then 98.6 is right here. Or we could be less than that by 2 degrees. So it would be 96.6 degrees. And so that is the range of a healthy temperature. So let me write that there. This is healthy. And so we know our number x can be between here. So this is an and problem. So if we have a temperature of 97.5, that's healthy. If we have a temperature of 99.2, that is considered healthy. So we want to come up with an inequality that would be unhealthy. So we're going to go ahead and set up our absolute value. So I'm going to go ahead and write here, this is for unhealthy. Remember, this would be our range for healthy. We got to make one for unhealthy. We're going to set it up absolute value, x minus, and we're going to go ahead and put in our perfect number, the one that is not going to change. We're going to take that and we're going to add to it or subtract to it. So we're going to put 98.6 right here. And then if it was an and problem, that would give us a healthy range. We want an unhealthy range. So we're not going to be using a less and. We're going to use a great or then symbol. And then we're going to just go ahead and have what we're going to be adding and subtracting. So that would be that 2 degrees. And so if you wanted the unhealthy temperatures, you could just take that, split it up, x minus 98.6. And remember, for the inequality, you flip it, make it negative, and x minus 98.6, and leave this one alone, greater than or equal to 2. You add 98.6. So that would be all numbers that are less than or equal to 98.6. And technically, because equal to would be considered healthy, my bad, I made a mistake, we really just want the greater than symbol. Because if it's equal to, that would be considered healthy. And I think I wrote 98.6 again when it should be 96.6. All right, and then here we're going to add 98.6, 98.6, and that would be numbers greater than 100.6. So we should not have an equal to, because if it is equal to, that is considered healthy. We want things that are unhealthy, so we would not put that equal to. Hopefully that makes sense. And so basically, you can be any numbers that are bigger than 100.6 are considered unhealthy. So if you have a temperature of 100.7, that's considered unhealthy. If you have a temperature that's 96.5, that is considered unhealthy. So either you have hyperthermia or you have a fever. Hopefully that helps. And I'm going to click on the next problem. I want you to try that one yourself. At least set up the inequality, and then in the next video, I'll solve that one for you. But thanks for watching. So this is the one I want you to try yourself, please. Example 2, a golf ball manufacturer puts 390 golf balls in each box. The box can be off by as much as 6 golf balls. Write and solve an absolute value inequality that displays the acceptable amount of golf balls that can be in a box.